Organizing Data, Module 2, Part 2. This presentation is broken up into 4 separate videos. The objectives are to distinguish between qualitative and quantitative data, to organize data to frequency charts, bar graphs, pie charts, stem and leaf graphs, and to identify the shape of a distribution of data. First, let's look at 2 different kinds of data. Qualitative data deals with qualities of something such as eye color, texture, or feelings. Quantitative data deals with quantities, things that can be measured with numbers such as weight, height, age, reaction time, temperature, and so forth. What are sometimes referred to as soft sciences tend to use a lot of qualitative data, while hard sciences tend to focus on quantitative data, although that is not a hard and fast rule by any means. Hard sciences would include things like physics and chemistry, and soft sciences would include social sciences such as sociology, psychology, economics, and political science. So let's look at some variables and decide which ones are qualitative and which are quantitative. If we were talking about a house, the color of the house would be a qualitative variable. The number of rooms in the house would be quantitative. If we were talking about a rabbit, the softness of its fur would be qualitative, and the weight of the rabbit would be quantitative. Hair color and race of participants in a study would be qualitative variables, whereas height and age of the participants would be quantitative. If we were conducting a survey for some place like Starbucks, the aroma, appearance, and taste of a drink would be qualitative variables, whereas the number of ounces in the drink, the price, and the temperature would be quantitative variables. Now let's talk about organizing qualitative data. Even though qualitative data isn't a number, we can still organize it by sorting. We can organize it into tables. We can construct bar graphs. We can construct pie charts. When data is collected from a survey or a designed experiment, it must be organized into manageable form. Data that is not organized is called raw data. So let's look at some ways to organize the data. We can use tables, graphs, or numerical summaries. In the next few slides, we will look at ways to organize qualitative data into tables. Remember, we said qualitative data represents qualities or characteristics of the objects being studied that are not numbers. Qualitative data may also be called categorical data because it allows you to sort the data into categories. Some examples might be eye color, hair color, race, religion, and those types of things. A frequency distribution lists each category of data and the number of occurrences for each of those categories, or the frequency of occurrence. We're going to work with M&Ms in this example. The data on the next slide represent the color of M&Ms in a bag of plain M&Ms. If we were in a classroom, I would give you a bag of M&Ms and you could conduct this study yourself. A frequency distribution of the color of plain M&Ms has been constructed by simply counting and tabulating what was in the bag. The bag had brown, yellow, red, orange, blue, and green M&Ms. Tick marks were just written on the tally sheet as they were sorted into their colors, and the frequency was recorded. In a case where we have a small number, such as the number of M&Ms in a bag, one could physically sort the colors into piles and then just count them and not actually use tally marks. The relative frequency is the proportion or percent of observations within a category, and it's found using the formula relative frequency is equal to the frequency divided by the sum of all the frequencies. A relative frequency distribution lists the relative frequency of each category of data, whereas a frequency distribution just lists the raw number of each of the items in that category. So for our M&M example, this means you would take the number you have in one category, say blue M&Ms, and divide it by the total number of items you have. How many M&Ms were in the bag? Now before we do any more arithmetic, let's go over the rules for rounding. When you round a number, you want to locate the position you are rounding to, for example, if it says tenths or hundredths. Then you look at the number immediately to the right of the digit you want to round to. It doesn't matter if there are 25 digits out there, the only one of interest is the one immediately to the right. If it is 5 or more, you increase the digit in the place that you want to round to by 1 and drop the remaining numbers. If the number immediately to the right is less than 5, you drop any digits to the right. Let's look at some examples. Round point 246 to the nearest hundredth. So the directions said find the digit in the hundredths place. That would be 4. Look at the digit immediately to the right, which is 6. It's bigger than 5, so we're going to round that 4 up to a 5, one more, and this number rounds to 0.25 or 25 hundredths. Round 1.627899954 to the nearest tenth. So we locate the digit in the tenth place, which is 6. We look at the number immediately to the right, which is a 2. Now we got all those big numbers further on out there, but we don't care about them. All we want to focus on is the 2. The 2 is less than 5, so that means we're going to drop all of those numbers, even if it breaks your heart to do so. So this number correctly rounds to 1.6 or 1 6/10. Round 1.53221 to the nearest whole number. The nearest whole number would be in the ones place, the place immediately to the left of the decimal point. The number immediately to its right is a 5, so that means we're going to add 1 to that 1 and make it a 2. So this number correctly rounds to the nearest whole number as a 2. Notice we do not put 2.0, because if you put 0.0, you're telling the reader that you actually rounded that to the nearest tenth, and that would not be correct. If you rounded the number 1.53221 to the nearest tenth, it would be 1.5. So you don't ever want any number after the digit that you rounded it to. Round 12.4567 to the nearest whole number. Again, the nearest whole number would be the 2. We look immediately to the right is a 4. It is less than 5, so we're going to drop everything to the right of the decimal. So this number correctly rounds to 12. And one last example, 12.3047, round that to the nearest hundredth. In the hundredth position, we have a 0. Immediately to the right, we have a 4. So we are going to drop the 47, and we are going to write 12.30. We have to write the 0 because this tells the reader that we have correctly rounded that to the hundredth position. If you don't put that 0, 12.3 would tell the reader that we rounded it to the tenth and not to the hundredth. Now we want to use frequency distribution obtained in the prior example to construct a relative frequency distribution of the color of plain M&Ms. Remember, our frequency distribution was that table that listed the number of all the different colors we had. Now we want to turn those into a relative frequency. So we had 12 brown M&Ms, and if you count all of the numbers in the frequency column, you'll find out that there were a total of 45 M&Ms in this bag. So 12 divided by 45 is equal to 0.27, and we're going to round these to the nearest hundredth. So then if we did yellow, we have 10 yellow M&Ms. We would divide 10 by 45 and get a decimal, and that would be our relative frequency for yellow. With 9, we would take 9 divided by 45 and so forth until you complete the frequency table. You will need to complete this table and use the results in the assessment that follows this presentation. Take care to correctly round your answers to 2 decimal places, because when the software checks your answers, it will not give you credit if you don't round correctly. Now we're going to look at how to construct bar graphs. A bar graph is constructed by labeling each category of data either on the horizontal or vertical axis, and the frequency or relative frequency of the category on the other axis. So you can make a bar graph using just the frequency, the raw counts, or you can make a bar graph using relative frequency, and you can make it vertical, going up and down, or you can turn it on its side. Any of those are called a bar graph. So let's use the M&M data to construct a frequency bar graph and also a relative frequency bar graph. So in the frequency bar graph, remember we had 12 brown, 10 yellow, 9 red, 6 orange, and 3 blue and 5 green M&Ms. I've labeled on the horizontal axis the colors of the M&Ms, and this is a frequency graph, so the frequency numbers are on the left. To construct a bar graph, you simply draw a horizontal line above the color beside the number on the vertical axis and make a rectangle. At this point, the video stops so that you can complete your bar graph and your relative frequency table. Then continue on with video part B.